Right, so we found all the angles inside that POS triangle. But clearly, if you observe carefully, I think you can understand this angle, this POS angle, that's not an acute angle according to the diagram. But we got our answer that's 60 degrees. So actually, we should change this diagram because clearly, according to this diagram, POS, an obtuse angle, so greater than 90 degrees. But we got 60 degrees. So therefore, I'm going to change this diagram. These are the answers, but the diagram I would like to change like this. Because that POS angle, I'm talking about this one, that's 60 degrees. So something like this. You can't draw a line like this. That's not correct. Because then that's an obtuse angle. But we didn't know that initially, right? So no worries. So this one's 60, 60, and 60. So basically, this POS triangle, uh, that's an equilateral triangle actually. So I can mark these three sides like this, three equal sides. And so we have all the other angles. Then now we can compute SOQ and OSQ, those two angles. By the way, this one equals to 30. Same diagram, I just change the position of S, right? This one still 90. Now QSO angle, which means this one, QOS, that one. For that, we can use that QSP angle, QSP, that total angle equals to 90 degrees. So QSO equals to, sorry, QSP equals to 90 degrees, right? And also, according to this diagram, QSP is the sum of two angles actually, QSO and OSP, like this. So this QSP equals to 90 degrees, this one 90, and OSP equals to 60. Hence, the other part, QSO should equals to 30. Otherwise, how would you create 90? So QSO equals to 30 degrees here. Then, and also we need SOQ angle. Right? SOQ angle. For that, it's very easy. Basically, this angle. The angle next to 60 degrees. There are two options. Either we can use this straight line and focus on this point O. Angles on a straight line equals to 180. Therefore, this part should equals to 120. Right? Because SOQ plus 60 degrees equals to 180. The total angle. Right? Then we can solve this one for SOQ. 180 minus 60, that is 120 degrees. Or there's another method, which is without using that line, you can actually use this triangle. QSO triangle because we know that sum of interior angles of a triangle equals to 180. Hence, 30 plus 30 plus that angle, the required angle, SOQ equals to 180. Here 60. I can move that to the other side. So SOQ equals to 180 minus 60. That is 120. So there are so many options which you can use to compute those angles, right? And also one important thing, this angle POQ, this one also equals to 180. Very obvious, like that, right? So we can do a lot of constructions, like for example, I can draw another horizontal line through S like this, right? So then that line parallel to this QP line, right? Then here, then you can use parallel lines also to compute those angles, right? I'll discuss another problem like that in a different session. So that's the process of computing angles, right? So yeah. Now what about this question? I should mention that this angle equals to 60. Actually, the same diagram, but here we are looking for something different. We need the area of the circle, right? So O is the center, right? And to compute the area of a circle, what do we need? What's the formula? Area of a circle. For that, we need the radius actually. So area of a circle equals to pi r squared. So to use that formula for this problem, clearly we need the radius of this circle. That's the distance from center to the circumference. This distance, this one, like that. We need those distances, basically the same length, radius, right? And OP, OS, OQ, those lengths also equal. That those are basically, that's the radius. And we need that to compute the area, because the radius of this circle is OP, which equals to OS, which equals to OQ. If you want to, you can mark these points and you can equal those lengths as well. But the point is, we need this length. If you can compute this length, then you will be able to compute the area, because that's a very easy, very simple formula, pi r square. So the idea is initially compute this radius, then substitute that radius here. Then that's your answer. Now it's matter of computing OP, OS, OQ, right? So for that, we do have the length of PS here. Length of PS equals to 4. So maybe we should use that, right? PS, that length. Let me mark that using the pink color, this length. That's 4. So clearly to compute a length, we need another length. So right now we have that. How are you going to use that length to compute any of these lengths? Right? So probably we should use the triangles. For that we need angles, and previously we found that QSP angle, this one, equals to 90 degrees because angles in a semicircle, right? I explained that in the previous video, so you can watch that and you can understand that because angles in a semicircle. Because QSP, that's a semicircle. Here, this is a semicircle. Sorry, this is a semicircle. So angles in a semicircle. So we can write that actually QSP equals to 90. The reason angles in a circle, angles in a semicircle, right? So let me mark that properly, 90 degrees. So that's quite helpful. Therefore, let me draw that triangle separately because that's a very important triangle for us because that's a right triangle, right angle triangle. 90 degrees, here 60. This length, PS length equals to 4. And also, we found that OP is a radius. And also, OS is also a radius. Yeah. Then what do you think? OP and OS both. Sorry. Here, one mistake. This is not O, this is point Q. Sorry. Here, this is point Q. I drew that QSP triangle because that's the uh, right angle triangle, right triangle. Right. Now, so yeah. Now, how would you compute OP? OP, OOS, OOQ? That's the question, right? So for this case, we have that length 4, so we should use that. What do you think? Maybe you can compute this angle initially, SQP, here 90 degrees, 60 degrees, the sum equals to 150. Then SQP angle, sum of these three angles equals to 180. Hence, SQP equals to 180 minus 150 because this part equals to 150. I move that sum to the other side. So 30 degrees. So now this is a 30, 60, 90 triangle. Hence, we can compute QP length. That's the strategy. I want you to compute QP initially, and that's the diameter. Basically, that's 2 times the radius. So if you can compute the diameter, then you can divide that one by 2 to get the radius. That is OP, OOS, OOQ. Then we can use that to compute the area of the circle using pi r square. So that's the thought process. Or you can use that 30, 60, 90 degrees, 30, 60, 90 triangle, or you can use trigonometry. If you have an idea about trigonometry, you can use that. So for this one, We want to compute the hypotenuse because that's the opposite side of 90 degrees, always. And if we are using 30 degrees, okay, let's use 30 degrees. Here 4 is the opposite side of 30 degrees. So now we are working with opposite and hypotenuse because we want to compute hypotenuse. So we can use sine 30 actually. I'll explain that. And also you can use 30, 60, 90 concept as well.